Take a look at its integral 0 to 1 of natural log of 1 plus x dx. How to evaluate this? The easiest way is to use the integration by part. Integral of u dv equals uv minus integral of v du. Let's u equal natural log of 1 plus x and dv equal dx. Then we have the u equal dx over 1 plus x and v equal x. Therefore, the integral of 1 of log 1 plus x dx equal the uv part and minus the v du part. Rearranging x over 1 plus x equal 1 minus 1 over 1 plus x. Therefore, we have integral of x dx over 1 plus x can be evaluated as x minus log of 1 plus x. We plug this integral into this equation, then we have this equation. Therefore, the integral of 0 to 1 of natural log of 1 plus x dx equal 2 log 2 minus 1. Can you evaluate this integral without using integration by part? Using integration by part is the most convenient, easiest way, but not using it poses a challenge. Let's see if we can evaluate this integral without using the integration by part. Let's do the double integral. First, we let log 1 plus x equals 0 to x, integral 0 to x of the t over 1 plus t. Then, the integral I can be rewritten in this type of double integral. Then we need to swap the order of the two integration. Let's take a look at the region. For any x from 0 to 1, t goes from 0 to x. Now after swapping for any t goes from 0 to 1, then x goes from t to 1. After swapping the two integration, we have I equals 0 to 1 of this integral of any x from t to 1 dx and dt over 1 plus t. That means for any t go from 0 to 1, we have x goes from t to 1. Since the integral from t to 1 of the x equal 1 plus 1 minus t, then the I equals 0 to 1 of 1 minus t dt over 1 plus t. Just plug this equation and go into this integral. Rearranging of this fraction and plug back into the integral, this is what we have. And since the integral 0 to 1, 2 dt over t plus 1 equal 2 log 2. Therefore, we have the final integral to be evaluated as 2 log 2 minus 1.